part 1. In order for me to find the equation of the normal, I need the gradient of the normal. So I'm going to find the gradient of the tangent first, which can very easily deduce for me the gradient of the normal. I need a point that is on this line, and it is going to be point P, where the parameter t is equal to P. So I'm going to find out what is dx dt, this is equal to 2t. I'm going to find out what is dy dt, this is equal to 2. So dy dx, this is going to be equal to 2 over 2t, this is 1 over t. This helps me to find the equation of the normal. So when the parameter t is equal to p, it is, according to the question, it is at a point p. So when at point p, let me just write. At point P, I know t is equal to P, which means that dy dx is equal to 1 over P, which means that x is equal to P squared, which means that y is equal to 2P. So this gives me the equation of the normal. The equation of the normal will be y minus away the y coordinate is equal to the gradient of the normal minus P of x minus away the x coordinate. So I have this equation of the normal. Part 1 done. Given that this normal cuts the curve again at the point Q, and this happens when P is equal to square root of 2, prove that the lines that are joining the origin to P and Q, they are perpendicular. Let me give you a few seconds. Can you think how you will solve this question? Okay, the question tells me that the normal at the point, the normal that we have just looked at, the normal at the point P. Okay, so let me just draw a normal. Okay, so let's say it is something that is like this. A normal at point P is going to be cutting the curve again at point Q. So what if the curve looks something that is like this? Let's say this. I don't know how it looks like. Okay, let's say this. Okay, so this point here is Q. So the normal at point P cuts the curve again at point Q. We want to try to prove that the origin to P and the origin to Q, they are perpendicular to each other. So we are trying to prove, let's say something like this. Perpendicular to each other based on the origin. I think a diagram really helps. You know, since young, I've been trained from my primary school, secondary school to draw a diagram. And I know my primary school teacher, she always forced me to draw the diagram into the script, which is a very, very good idea, because the diagram is part and parcel of the thought process. In order for me to draw the diagram, I need to analyze the situation. So in a way, what she has instilled, right, is to really push so that you know, a situational exploration analysis, right, is already part of the solution. So I like to draw diagrams into my script, and I think some of you don't tend to draw it into your script. Maybe you draw it in your head or somewhere else. But no matter what, just find a way to draw the diagram if you feel that it helps. Okay, so I'm looking at a situation that is like this, and in order for me to prove that OP is perpendicular to OQ, I'm going to use coordinate geometry. I'm going to find the gradient of the line that passes through OP. Then I'm going to find the gradient of the line that passes through OQ. Because from coordinate geometry, if I have the gradient of the two lines, I multiply them together. If it gives me 1, then I can actually prove that they are perpendicular to each other. If I want to prove two lines are perpendicular to each other, I have learned before, gradient. This times this is equal to -1. Okay, that's why refer as much as possible, because every reference will get your region here bigger. So we have this, which means that if I am going to try to execute it this way, I need the coordinates of point Q. I already have the coordinates of point P, because the question tells me that P is equal to square root of 2. So if P is equal to square root of 2, that means at point P where T is equal to square root of 2. I know what is the x coordinate. X coordinate is going to be square root of 2 squared. This is equal to 2. the y coordinate is going to be 2 square root of 2. So point P here is 2 square root of 2. And point P here is when t is equal to square root of 2. This is given to me by the question. I need to find something about Q. This, the moment when I see this, right, it clicks to whatever that I've learned before about finding intersection between a curve that is defined parametrically and a line. I mean, and another one that is defined in a Cartesian way, solve simultaneous equation. It has always been solving simultaneous equation. So I'm going to go for x is equal to t squared as equation number 1, y is equal to 2t as equation number 2. This belongs to the curve. And for the normal, I'm going to call it equation number 3, y minus 2p is equal to minus p, x minus p squared, which is y minus 2 square root of 2 is equal to minus square root of 2. X minus square root of 2 squared is going to be 2. This will be my equation number 3. Solving simultaneous equation, I'm going to sub equation number 1 and equation number 2 into equation number 3, simultaneous equation. At this point here, they happen simultaneously. These two represent the curve. This represents the line. These three equations must happen simultaneously. So we have y is going to be equal to 2t minus 2 square root of 2 is equal to minus square root of 2. X is equal to t squared minus 2. Solving for this, you're going to get two values of t, at least two. I'm expecting this. And one of the values for t should be equal to square root of 2 because this is also the point of intersection between the curve and the line. So as expected, one of the t is equal to square root of 2. The other t is going to be equal to minus 2 or minus 2 square root of 2. I'm going to say this as the t that gives me the point Q. So at point Q, I believe t is going to be equal to this. So x is going to be equal to t squared. So it's going to be minus 2 square root of 2 squared. This is going to be equal to 8. Then y is going to be equal to minus 2 square root of 2. Therefore, point Q is having a coordinate of 8 and minus 2 square root of 2. So this is going to be 8 minus 2 square root of 2. And t is this, minus 2 square root of 2. I think we are almost there. We should be able to score for the full 5 marks because I have already gotten myself to a place where I can just just execute what I've already been practicing for. The next thing I'm going to do is I'm going to find the gradient of the line that passes through O and P. So O and P, this is the coordinate. O is 0, 0. So we have a square root of 2 minus 0 divided by 2 minus 0. This is equal to 1 over square root of 2. Then the gradient of OQ, this is going to be equal to minus 2 square root of 2 minus 0 divided by 8 minus. So MOP multiplied by MOQ is going to be 1 over square root of 2 multiplied by minus square root of 2. It is equal to minus 1. Therefore, OP is going to be perpendicular to OQ. Well, I don't know how many of you tried this and got